Hi, I am Shubham, and this is the part B of our assignment one. So basically, we are given the CIF file of BaTiO3 crystal, and we have to modify it to get the structures of different compounds, different crystals. So let's start with what are the contents of these CF file. So first, the chemical compound is we are given BaTiO3. So the chemical common name it is Ba. Ba is one atom, Ti is one atom, and we have three oxygen. And these are the cell parameters. These A, B, C, and alpha, beta, gamma. We have provided the data. Then the cell volume and the space group, how it is symmetric about its axis and its planes. So it is primitive, and one is there is no overall symmetry. And then come to these are the different parameters based on which like it is like fractional coordinates and symbols, labels. So these are the percentage occupancy, we have barium, titanium, and oxygen. So these are the percentage, how much they should occupy, how much percentage they are occupying of their volume. So it is total, they're occupying fully. And these are the x and y coordinates based on which they are provided the location in the unit cell. So barium zeroth atom is at 0.5, 0.5, 0.5. Titanium for titanium 1 is at 0, 0, 0. Oxygen 2, 3. These are the three different kinds of oxygen, three different kinds, not three different position of the oxygen based on which they have different coordinates. So these are the coordinates of them, and these are the fractional coordinates: 0.5 of the unit cell in X, 0.5 of the B, and 0.5 of the C. So these are the fractional coordinates. So let's modify these and get our different kinds of data. So GAP. So GAP is like zinc blende structure, and for that we have to provided it it has a unit length of cell length of 5.448 angstrom. So we have made changes according to these, and based on that we have to change, here it is FCC, but um, we don't have to change it to different, because we are specifying the different kinds of atoms present here. If there is some symmetry and we have to change it, we have to find other symmetric atom based on that, so that we can change here. But we are specifying each and every atom here, so we don't need to change this part. And similarly, we know that zinc blende structure, all the in zinc blende structure, the similar to that, gallium is occupying the alternate tetrahedral voids, and phosphorus is creating the FCC. So there are four kinds of phosphorus, uh, and their percentage occupancy is 100% of their whatever the site they are occupying. And these are the alternate tetrahedral voids. So if the first gallium is at 0.25, 0.25, 0.25, so gallium 2 will be at 0.75, 0.75, 0.25. Similarly, gallium 3 and gallium 4. These will be occupying the alternate tetrahedral voids, and these phosphorus will be forming the FCC of the structure. And now K2O. K2O is like antifluorite. Antifluorite basically here is all the tetrahedral voids will be occupied by the metal, and the tetra and the FCC will be created by the oxygen here. So all the tetrahedral voids, we have specified all the tetrahedral voids here, like 8 tetrahedral voids, and these are their fractional coordinates, like 0.25, 0.25, 0.25, and all the 8 sites they are occupying. and also oxygen is forming the FCC here. So these are O2, O3, O1, and O2. Similar to this, we don't have to change the P1 because we are specifying each and every atom here. So it's like that. And we have given the cell length of 6.4, 6.4, and 6.4. Basically, these are cubic type. Now, calcium CaTe structure. So it is similar to the rock salt structure, in which in the rock salt, all the octahedral voids are occupied by the voids are occupied by the metal, and FCC is formed by the non-metal. So here, calcium will occupy all the octahedral voids. Octahedral voids are in the center of the unit cell and at the mid of the edges, all the mid of the edges. So this will form the rock salt structure. Ca, C1, C2, C3, C1, C2, C3, C4. So basically, these are formed like this: calcium 0, 0, 0, 0, 0.5. Like these are the mid edges. Calcium 3, calcium 4, tellurium 1, tellurium 2, tellurium 3, tellurium 4. So tellurium will be occupying the tellurium will be occupying the tellurium will make the FCC, and calcium will make calcium will make the fill the octahedral voids. And next we have CeO₂ structure similar to this also. These are the fluorite structure. Basically, it is up here. It is opposite. The metal will form the FCC, and the non-metal will be in the tetrahedral voids. Similarly, we have all the tetrahedral voids will be occupied by oxygen, and Ce is occupying the this void. C is making the FCC. And next we have AuZn. It is like CsCl structure. It is a primitive structure. It is not FCC or body center. It's not. It is primitive, in which in the central cubic void there is it is occupied by zinc. So it is 0.5, 0.5, 0.5, and there is only one type of gold here. So it was by unit translation. It will be we will get the different sides. So this is like that, and now we will open it in the VESTA so that we can get what are we will open it in VESTA to see the structures of the files. So this is the structure of the BATiO3 we have been provided. So like the central, it is all the FCC is obtained by different at sorry. So it is the BATiO3 structure we have been provided. We will modify it to get the other structures. So zinc blende structure. This is the zinc blende structure. We have modified the it. So we can see the alternate tetrahedral voids occupied here. Here it is like we can see this view. If we get only the alternate tetrahedral voids are occupying, like the green one denoting the metal, like here gallium. So here it is occupied, here it is not occupied. Then here it is occupied, here it is not occupied. Here it is occupied, here it is not occupied. So the alternate tetrahedral voids are occupied by gallium, and the phosphorus is forming the FCC. Similarly, K2O, like K2O is antifluorite. So here the potassium is like this. Potassium is here, and oxygen is forming the FCC. And all the eight tetrahedral voids, like see, we can see eight here. All the tetrahedral voids here, these four, these eight we can see are occupied by are occupied by potassium, like this. These are similar to rock salt structure. In rock salt structure, basically all tetrahedral voids are occupied by calcium. So all the mid of the edges and central, here it is central, are occupied by calcium, and T is forming the FCC. And now fluorite structure. In fluorite, the metal is forming the FCC, and non-metal is forming non-metal is occupying the yeah, tetrahedral voids. So we can see like these are forming these are occupying the tetrahedral voids, and these are forming the FCC. Now AuZn, it is similar to CsCl structure. It is like a primitive structure in which like all the corners are occupied by gold, and Zn is forming just a cubic void, the space bit formed by the left behind the primitive atoms. And now BaTiO3 structure. We are provided the BaTiO3 structure. We can change the parameters, the colors, the size here also. We can change the color here from we can change the phosphorus color to black here, and gallium to gray. Similarly, like here also, we can change the oxygen to, let's say, blue, and potassium to, let's say, violet. So these are the different. We can similarly change the colors for better observation. We can also like make different styles, like these are ball and stick type space filling, this will be occupying all the space, but ball and stick is fine for better observation of the what are the bonds and what are the structure formed. So thank you.